Attendees are in listen-only mode.
Welcome, everyone. My name is Tracy Fitzpatrick, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We're very excited to host today's webinar, Develop Your AI Strategy with These Trends in Mind. Presenting today's topic will be Tarun Sukhani. Tarun is an IT executive, educator, author, international speaker, security expert, agile coach, and coder with over 19 years of combined professional experience in both the U.S. and internationally. He's skilled in big data, data science, Hadoop, Hive, HP Base, among others. He has facilitated training workshops in Malaysia, Singapore, and various other Asia-Pacific countries, focusing in areas of project management, consulting, leadership and management, as well as security, teamwork, and other soft skills, in addition to big data, data science, and machine learning. Now, please bear in mind that this is an overview of a very robust topic. We do offer a collection of technical and business courses that can be tailored towards your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you will get free access to the recording in the next 24 hours via email. Netcom Learning does help customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize, and they encompass people, process, and technology training. Today's presentation is from the Data and AI practice area. Netcom Learning offers a comprehensive training portfolio for data and AI courses as well. And here is our list of the upcoming classes on our public schedule. And let me just read those for you. They're all up there on your screens. We are starting June 25th. Will be Perform Cloud Data Science with Azure Machine Learning. On June 4th, Practical Data Science with Python. Practical Science Data with R. Actually, that's June 11th. Also on June the 4th, Beginning Application Development with TensorFlow and Keras. June 11th, we have Beginning Data Analysts with Python and Jupyter, as well as Deep Learning Explained, and Perform Cloud Data Science with Azure Machine Learning, MOD. And we can also deliver private training to teams, of which the learning plan can be customized to the specific needs of you and your audience. These offerings can be found with a simple search on our website at netcomlearning.com. So why should you all attend this webinar today? Netcom Learning presents an important installment in its Developing Your AI Strategy with These Trends in Mind. In this webinar, we're going to present the key concepts of AI and explain the organizational steps to prepare for the change inclusive of what is happening in the corporate world to its implications. The webinar not only helps us in understanding how AI fits into organizations' IT strategies, but also what organizations are doing with AI. And now I'd like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to adjust the window size to your liking. Simply hit the Escape key and find the Zoom button on the top left corner of your GoToWebinar viewer. Everyone has been muted except for our presenters. Please feel free to submit any questions you do have for the presenters here in the questions pane, and we will address them at the end of the session. A PDF copy of today's slides are also in the handout sections of your GoToWebinar viewer. And now I'm going to pass this over to Tarun, who will be presenting today's topic. Okay, Tarun, go ahead, you're live.
Okay, can you hear me?
You are loud and clear.
Okay, excellent. Okay, so for the next about 45 minutes, we're going to be talking about developing your AI strategy with these particular trends in mind. The agenda is key concepts of AI, trends, so we'll cover the trends, what organizations are doing with AI, and then we'll talk about how AI fits into organizations' IT strategies, and then finally we'll end with how will AI interconnect organizations and the organizational ecosystems. Let me minimize this, blocking my screen. Okay, so what is artificial intelligence? So artificial intelligence is essentially using computers to solve problems or make automated decisions. So for example, for tasks that when done by humans, if they typically require quote unquote intelligence, uh, that would be under that banner. Of course, we have to figure out what intelligence actually is. And so we've divided intelligence into two different categories. One is called strong artificial intelligence, also known as uh, uh, artificial general intelligence or AGI. And artificial general intelligence is basically computers thinking at a level that meets or surpasses people, computers engaging in abstract reasoning and thinking. This is not what we have today. Okay, so and there's no evidence to indicate that we're even close to this. What we do have today is weak pattern-based artificial intelligence, also known as artificial narrow intelligence or ANI. And this is where all the money is pouring in from companies like Google, Facebook, Amazon, etc. And what they're doing is they're using computers and algorithms to solve problems by detecting useful patterns in massive amounts of data. And this type of pattern-based AI is an extremely powerful business tool, primarily because it can be used to automate many processes that we could not automate before. So, for example, driving, language translation, cancer diagnosis, fraud detection, so on and so forth. So therefore, this is the dominant mode of AI that we see today. Okay, so within this type of artificial narrow intelligence, we have two major AI techniques. The first one is logic and rules-based. This is actually an older approach, but it's still relevant today. And you can liken this to, for example, a set of if-then-else statements. So, for example, if my tax bracket is greater than 50,000, then apply these deductions, blah, blah, blah. Right? So that's what we typically would call business rules based, uh, narrow intelligence. And of course, what is becoming very popular today is machine learning, which is the pattern-based approach. And of course, we see many applications of that. Machine translation, of course, is just one field within artificial intelligence. And if we take a look broader view, what are the types of AI being used in businesses today? We can see, of course, machine learning is there. In particular, deep learning now has become de rigueur, because of all of this achievements in self-driving cars and universal translation and so on and so forth. But anyway, machine translation falls under the banner of natural language processing, and so here you can see NLP, clearly delineated there, and NLP also includes speech, by the way, and of course, expert systems. That's what that's the more logic or rules-based inference systems. But we also include combinatorial optimization under artificial intelligence as well. So, of course, the most common application of this is logistics or supply chain management. And then finally, we rounded off with computer vision and robotics. And computer vision, of course, has kind of gained momentum in recent years due to deep learning, and the accuracy rates have in fact exceeded human capacity within this very narrow task. So just to get more into detail about the logic and rules-based approach, This just goes into some bullet points regarding it. But basically, the idea here is that you have a set of business rules, and these business rules drive reasoning about a particular decision that needs to be made. Um, and expert systems, for example, legal systems, tax systems, accounting systems, so on and so forth. These fall under the banner of expert systems. Okay, and then as I mentioned earlier, machine learning has kind of taken over in terms of popularity. Of course, that doesn't invalidate rules-based approaches, and in fact, as we'll see very soon, a combination of both approaches is better than either approach alone. And in fact, we could add even further to that by saying that human beings plus machines are better than just machines or human beings alone. So here we can see under machine learning that what has really advanced in the last 10 years, take or what are plus or minus 5 years, is the advancement of algorithms, in particular deep learning algorithms, such as CNNs and RNNs, which really allow us to do pattern recognition, feature engineering, feature selection, much better than we've ever done before. And they work usually on very large data sets that, again, have really not been made possible until very recently, thanks largely to the World Wide Web. So here we can see some machine learning use cases. Of course, self-driving cars. Here's the the Google Waymo kind of self-driving car. Netflix, of course, for recommendations, and computer translation, Google Translate, obviously. In terms of machine learning main points, we have, of course, the learning aspect of it, the pattern detection portion of it, the massive amounts of data, and this idea of self-programming, which basically means that we don't write the rules, the machine figures or infers the rules on its own. So an example of this is an email spam filter. Now, we could do it the really hard way, which is we could define a set of rules, saying that if an email contains these words or these phrases or this type of grammar, blah, 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 it's a spam. But we could spend eons doing this, given the vast expanse of the English language and grammar and things like that. So we obviously don't want to do that. We would rather that we could create a rules inference engine that would figure out that, hey, this email is a spam email. And in the technique that's mentioned here in particular, we're using a Bayesian inference. So that is a type of conditional probability. And that basically says is, hey, I noticed that previous emails that have the words earned cash or Nigerian prince generally tend to be email that is spam and is discarded. And so therefore I will mark this as spam as well because it contains the same or similar words. Of course, if we were to use that type of logic exclusively, we would probably have a lot of false positives. But this is not presentation on how to write machine learning algorithms. We'll leave that for another presentation. What about intelligent results without intelligence? So for example, for some tasks, of course not all, that do require intelligence, we can basically use a proxy or a pattern rather than outright algorithmic intelligence to solve that problem. So what is an example of that? Well, machine translation, specifically statistical machine translation, is a good example of that. Why? Because if you look at certain languages, for example, if we just use a pure algorithmic rules, inference or pattern-based approach, chances are we're not going to get a very perfect translation. And in fact, it'll seem kind of uncanny or weird because no one really talks like that. So what we do instead is say, hey, let's take a look at some examples of how human beings have translated certain sentences in other languages into the destination language, and use that as a basis for our translation. So in other words, that that human translation stands in as a proxy and is used to learn what is an effective translation. Basically, another example of that, what I just talked about, is what happened with AlphaGo versus AlphaZero. I don't know how much you guys know about that, but basically, AlphaGo was trained initially on human games, on how humans played Go. Whereas AlphaZero was a complete tabula rasa, where there was no human game input, and the machine just learned everything on its own. And so that really shows you the difference in approach, because in the former one, there was a human input or statistical kind of element to it. What about hybrid systems? So this is what I talked about earlier, where we combine machine learning and rules-based approaches together. And we see that, for example, in game engines like chess. So that's commonly used in a lot of game engines, but it's also, of course, used in self-driving cars. So the idea is that we don't just use one type of pattern recognition approach and then forego an inference or rules-based approach. We kind of combine both. So and again, that this raises the issue of humans working alongside computers tends to be better than either alone. And that's probably going to be true for a long time. Despite what the naysayers say, there's no evidence that that's going to disappear anytime soon. So what are the limits on artificial intelligence? Well, we know that what we've done, I mean, like self-driving cars and things like that, I mean, that was not even possible, 15 years ago. So a lot of this stuff has really come, kind of full circle in the last 15 years. And by full circle, I mean that, we're using artificial neural networks to do this. And some time ago, they weren't really the darling of AI, but now they are. What about the limits? So many things, are still beyond the realm of AI. There are no thinking computers really in the sense that we think about perception and understanding. These things that we're building don't have that. And the other thing is that AI systems tend to have accuracy limits. Deep learning is one notable exception to that because it tends to monotonically increase in accuracy depending on how much data you feed it. But then again, human beings don't need to be fed millions of rows of data to figure things out. We're really good at sparse learning, and that's something that machines aren't great at. So, and then the last thing is, a lot of these advanced deep neural networks are very hard to interpret. They're kind of like black boxes. Okay, so why don't we get into organizations that are using now AI, and let's see how they're applying it. So for one thing is that we can see them; they're obviously applying it across their systems. But basically, the goal here is to be better able to manage repeatable processes, improve workflow standardization, reduce multiple systems reliance, this type of frictionless straight-through process, What the hell does that mean? It means that we avoid human beings as much as possible, uh, and then try to go straight through from one machine to another. This reduces errors, obviously, and operating cost. Um, uh, the use of AI can also benefit us in terms of risk management and auditing. And of course, finally, it can enhance customer experience and engagement. Of course, recommendation systems are a good example of that. But another example of that is chatbots. This just shows what are the roles that are created by AI, because a lot of people talk about job loss and things like that. Well, the reality is that a new set of jobs will be created through the use of AI, and we can see some examples here. But they fall into three general categories of jobs: trainers, explainers, and sustainers. So I'm not going to go into this too much, but because it's not about jobs. So we can use AI also to target how organizations work. If we look across a company and what areas companies want to improve, we have the organization, we have technology, we have KPIs, people and culture, governance and compliance, competency and performance, partners and alliances, and finally processes and methods. Basically, AI, can be used across the board, across these many different aspects of the operation of a company. So really, the goal here is to maximize human potential by using these so-called smart technologies. One of the biggest, use cases is business process automation, and so we can see, that happening here on the data side, on the kind of signals and triggers side, or the so-called trend side, on human behavior side, meaning that well, everyone knows about Facebook, of course, now, and what Facebook is doing. It's obviously monitoring your behavior and trying to model your behavior, your likes and dislikes, and so on. And then probability, which is, hey, predictive, right? So what is the likelihood that so and so, such and such is going to happen? So we can see that that these different domains are kind of combining and interesting in different ways. So this just covers the different application domains where AI is being applied nowadays. So of course it's broad, and it covers like a lot of stuff. So I'm not going to obviously go through everything here. Okay, let's talk about how has AI been used in business. So over the years, AI research has enabled many technological advances in business, including virtual agents and chatbots. So I'm sure you guys have heard of, Amazon Echo and SIRI and Google and all that stuff. So those are virtual agents. Suggestive web searches. So that's the autofill that you get, as you're typing. And in fact, in Google I/O 2018, just I think it was about a few days back or something, they have a new feature for email that can also do this suggestive kind of email completion. Targeted advertising, of course, that's an old application. Pattern recognition, predictive analytics, voice and speech recognition, facial recognition, machine translation, autonomous driving, automatic scheduling. So many of these are now commonplace and being used in businesses actively today. Okay, so what are the types of impacts? So one type of impact is on the robotic stuff. So I don't know if you guys have seen the Amazon and Alibaba warehouses, but they have these warehouse robots, and they pick up goods and stuff, and they move them around. And so that's an example of an automated robotic process. On the machine learning side, it's a software driven. So we have, search and recommendations and, learning systems, machine learning, value and risk profiling, probability modeling, and well, the list goes on and on. So where can we apply it? Obviously, strategy, organization, brand management, finance, human capital. I mean, you know, we've already discussed some of these already. The point is that you can use it throughout your company, in every operational aspect, basically. You can use it throughout your company. So you can use it to improve customer services and experience, automate workloads, optimize logistics, increase output and efficiency, prevent outages, predict performance, predict behavior, manage and analyze data, improve your marketing, advertising, better decision making, reduce risk and fraud. And then depending on the type of AI, smart programs can perform specific individual tasks such as medical diagnosis, electronic trading, robot control, or they can do complex cognitive tasks, for example, speech recognition, facial recognition, and behavioral, even emotional detection, you know, like looking at someone's face and telling if they're pissed off or not or something, or just by listening to their voice. So in fact, there are systems in place today in call centers that can detect whether you're pissed off or not or whatever, and alert the customer service representative. So yeah, I mean that's pretty amazing stuff. I'm pretty much done. I'm a little bit early, but I guess that gives us more time to.
So you've wrapped up here, Tarun. Thank you so much. And now we're going to just make a few announcements about some additional things we have going on here. Okay, so up next, as we celebrate our 20th anniversary to serve you with the best-in-class IT and business certification training, we bring you unbeatable a 20th year celebration offer this month to make your learning even more fantastic. We are actually offering up to 50% off on some of our popular courses, which you can see right up there on your screens. And Netcom Learning offers a comprehensive portfolio for all data and AI courses. Again, you can check those out on your screen. We do offer team training that can be customized and accelerated to meet your organization's specific needs as well. You can contact us today to be connected to one of our learning consultants to help advise you on your specific needs. Simply email a webinar at netcomlearning.com or search our catalog at netcomlearning.com as well. And we all know that technical skills are necessary to empower our careers, but do you need to improve or upgrade your leadership skills as well in order to accelerate your career? Along with your technical abilities, develop the skills you need to manage yourself, others, and business better. Welcome to Starter Learning, a collaborative knowledge platform bringing the world's best business and leadership insights from Fortune 1000 leaders, best-selling authors, and Ivy League professors. Further, if you are interested in learning from the top American leaders, you can log on to the e-learning platform at starterlearning.com and avail the special promotion meant for first-time users. Use your coupon code SARTER10 and begin your leadership journey now. And right now we do want to launch a quick poll to find out how many people might be interested in taking some additional training. So please take a few moments to fill that out before you all log off and get back to work. And we do offer a lot more informative webinars coming up, so go to netcomlearning.com/webinars in order to register. And don't forget to like and follow our social media pages to get the latest technology updates. You can refer to our GoToWebinar chat window for all. And now let's get to some of those questions. First one is from Ashok, who would like to know, what is the difference between MI and AI, or I'm sorry, ML, and is ML part of AI?
Okay, I'm assuming you can still hear me.
Yes, we can.
Okay, so basically, I do have a diagram, but I did not include it in these slides. But basically, it does show you very clearly what is the difference between AI, ML, and DL. So now I have to verbally describe it, so I'll do my best to do that. Basically, yes, AI is an umbrella term. It does encompass rules-based, inference-based systems. It includes machine learning or pattern-based machine learning, which is often nowadays called traditional machine learning, which is largely statistical in nature, and it covers Bayesian inference and information theory, i.e., decision trees, random forest, support vector machines, and so on and so forth. And then finally, we have representation learning. And deep learning is a type of representation learning. And so the difference is that, very simply, in AI, you have to define the features and the rules. In machine learning, traditional machine learning, you have to define the features but not the rules. And in representation learning, particularly deep learning, you neither have to define the rules or the features. That's it.
Okay, next question. Also, could you highlight the difference among ML, AI, and deep learning? And can you
Okay.
suggest a starting point to learn AI and ML?
Okay, so I think I've already done a pretty good job of delineating AI/ML DL. Just to make a further point on that, as I stated, DL is a type of representation learning. And representation learning is almost always done using an artificial neural network, primarily because ANNs are really good at representation learning. And deep neural networks are basically artificial neural networks with a lot of hidden layers. Obviously, I'm assuming you know what an artificial neural network is and what hidden layers are. If you don't, I guess I'd have to answer another question. But the second part of that question is how do you get started? And in AI, ML, DL, and the answer is just take a few minutes to go on YouTube and watch some videos from Siraj and watch some videos from 3 Blue, 1 Brown or something like that. I can't really remember the name, but you'll see it. And they do a really good job within a very short period of time to actually show you, where to begin with AI MLDL, what books to read, what courses to take, and so on and so forth. And of course, I think that Netcom obviously offers courses in these subjects as well. But if you just want a quick 5-minute or 10-minute primer, I would definitely recommend those type of resources.
Great, thanks, Tarun. Next question is from Michelle. I'm in the legal profession, operations. How have you seen AI ML being used to protect legal operations from a risk management perspective?
Okay, so I'm not a lawyer, so I'll put that disclaimer out right away. Now that being said, from a risk management perspective, within, for example, the legal profession, AI is being actively used, in particular in rules-based inference. So the legal profession is essentially a how certain decisions are made. So that lends itself quite well, to the more rules-based type of AI. You don't even have to worry about pattern recognition there. When we look at risk management, for example, we're essentially defining certain rules and conditions that, when met, trigger certain events. And really, so that's kind of like the main use case for AI within risk management, within either the legal profession or auditing or accounting. So believe it or not, all of those three have something in common. I'm sorry that I can't go into any detail because I'm not a lawyer, so I'm not going to try.
And you don't claim to be. There you go. Okay, so any other final thoughts before we end today's session, Tarun?
Not from me.
Okay, Tarun, we want to thank you and to all of you for joining us today. And if you do happen to come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time, and we will address them. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.